All right, welcome everybody. Let's program something. So today what I was thinking of was to program something a little bit like a game I found called Sandbox for Android. And um, it is a little bit, let's play some video here. It's a little bit, yeah, it's like a physics particle simulator, if you will, right? And so you can like play with particles, I guess. That's kind of the point, right? And so you just you have it models heat. It has like flow, I guess, which I'm not sure how that works. Maybe that's some sort of pressure thing, but no, it's not a pressure thing. I'm pretty sure it's not a pressure thing, but I want it to be a pressure thing in my engine. So basically, I want to make something like this, which I guess right now you can't see much about that. But is that the guy that makes this game actually? Yeah, some pretty cool stuff in here. Um, anyway, so yeah, it's just like a particle-based physics simulation of some kind. It's not really a simulation, kind of like a physics game, if you will, right? So for that, we're going to use my engine Ensym3, which is a totally work in progress name for the engine, and it is a just a simple entity component based um, engine. It's really pretty simple, and it doesn't really have anything that supports physics or collision or anything like that. And we're not going to be using the engine for a lot right here because I just want to use this engine to like get some high performance and be able to optimize it a lot and not have to worry about writing rendering code as much anyways, like all the setup code and whatnot. So I'm on a Unix system. Um, I'm on an Arch Linux system here. And so that's why everything looks like that. In case you're not familiar, it doesn't really matter. I'm going to program in C++, and C++ looks pretty much the same all across platforms, unless you're talking about very specific OS system calls, stuff like that, that we don't really care about. So, let's open Qt Creator because I'm not about to program in fucking Vim. I mean, I like Vim, but wow, for big projects, no please, no thank you. I would rather use something that I don't that I know better. Let's say. Okay. Um, and there's a whole lot of shit here still loading, so just wait for that. And so what I was thinking was that we should first get a very simple system of like maybe drawing stuff on the screen. Haven't done that before, like drawing like circle shapes and whatnot. And coming up with a very high performance grid system. So we need some sort of array of data. If we look in like the cells program, I actually have something like that. So I'll actually run that real quick. So we have uh, build and build, what's it called? Build cells? Something like that. Why is it building so long? What did I do? Did I fuck some up? I don't know. Okay, and so I'm going to show you this program that's just a simple game of life, Conway's game of life simulation. It's a cellular automaton type deal. And it's actually rendering fuck knows how many cells here. That's a lot of cells that it's rendering. It's a multi-threaded thing where the rendering is completely detached from the processing. And so you see that this is not quite in sync and everything, but it's a very high performance, as you can tell. There's a lot of these cells, and yeah, this is one game object, so it's not that impressive, right? But we basically want a very simple way to draw basically this, right? Basically, we want to draw little squares. We want to be able to change the color and I think that's about it actually. The color is all we care about. And well, the position obviously when I'm able to move and have all sorts of properties to the cells. So let's actually call them like something else. Let's call them particles because that's like a little bit. Actually, that's more confusing. Um, let's call them cells. Let's call them cells because it's a grid and there's cells in the grid, right? Right. So this is how that code looks. And this is the code for the cells program, right? The one that has Conway's Game of Life, and it's pretty basic. It's multi-threaded, but it's pretty basic. Um, yeah, here it has this update function that's called from a thread, and in a thread like that's running in a thread, and it calls back into the rendering code to set a drawable. And there is supposed to be a mutex somewhere, but I don't know. So all sorts of issues with this. We're not going to be copying any code from this. Let me just make sure haven't changed anything. Okay, so we'll make a new executable here. Let's call this particles is bad because if we look at my roadmap, actually right quick here, you can see that I have in my projects thing features for 1.0. We do actually have a particle system somewhere in here that we want to make. There, right here. Look, there, particle system. So definitely not gonna fuck with that too much. Calling stuff particle, all that, not gonna touch that. What are we gonna call this? Let's call it Sandbox as an homage to what we're trying to copy here. Like not copy, but like that gave me the inspiration to make this, right? So now that we've made this, let's include engine, and that should be it. Make a little int main here. Application. How does this work? Is it auto app? Yeah. Application. Title. Actually, we can do. Sorry, I went through so many like iterations with this entire thing that I'm really like confused sometimes as to how to do what, you know. So sandbox. Let's make that like 1280 by 720, and the res list is gonna be, let's just keep that, doesn't really matter. Okay, auto reference window is app window, auto reference world is app. Well, the world is really just an object that keeps track of all the entities that we have, and it kind of does all the updating, whatever. The responsibilities on the window and the world and the app is not really separated properly yet. So in case you're wondering about the we return app.run because that returns something, I don't know, CMake lists. Okay, now in our CMake lists, we want to actually do some add executable. What did we call that? Sandbox. Sandbox main CPP. We might add more to that. Target link libraries. Sandbox engine. That's how we link to the engine, which is built up here. This is the engine stuff. Right, okay. So for starters, let's just make a really simple thing here. Just so to demonstrate. Add entity. What kind of entity do we want? Let's just a position. Yeah, let's just leave that. Let's lock that. Okay. All right. So this is basic setup code, right? We just say like add component, sprite component or some shit. Let's make a sprite component here, and let's give it it's a constructor of that. I don't remember. Parent position sprite size. Okay. Wait, parent position? Really? Don't we do that? Anyways. Haven't used this in a while. Fuck it, can't be that bad, right? Can't hurt to try. 0, 0 is fine, I guess, and then we actually want overload resolution, so we need to do this. And then this is gonna be the size, which will make like 100 by 100. Sorry for all the mess here. It's just, yeah. Trying to get back used to this thing, and also set frame rate limit to 60. Alright, see if that runs. Oh, hold on, we want to make sandbox only, not the other shit. Right, after all this nasty setup that we made, we should be able to start programming. And I know there's a whole lot of issues here. That's not the one I wanted to. Why is it sprite 1? Hold the fuck on. Oh fuck, I'm retarded. This is not supposed to be main.cpp, this is supposed to be sandbox.cpp. Wow. Nobody corrected me on that? I'm kidding, I'm not live. Alright. I'm so funny. It's incredible. Okay, there we go. There's our window. We have a little square, 100 by 100. And yeah, that's about it. Default color is green, just so you see it. We have some resources that we loaded. Well, we'll not worry about resources for now. Oh, right, we did actually just add a way to render text. I forgot about that. How did that work, actually? We need that anyways to display like performance stats and all that. Like this. Okay, we do label, we make a GUI element to the app, and then we set a lambda. Okay, yeah, ugly, but works. I don't like ugly, but I like when it works, so trade-off, you know what I'm saying? Pew pew. Not high, by the way. Right. So let's get started on thinking about how this is gonna work. So let's make a compound. Let's first make some basic things here. So we'll make a cell, and this cell, actually now if I search for cell, there's 3 different cell classes. Fuck it. So we're talking about a cell that has struct first of all, fucking hell. It has its own position. Actually, does it? It's very data heavy. Let's not do that. It doesn't know its own position. Actually, could know its own index. That could be okay, but that's kind of annoying. Do we want to do this functional, or do we want to do this object-oriented? Someone's probably screaming at their screen like, "Oh, it's not called functional. It's called this." I don't know. I wouldn't know. I'm only a student in computer science, not fucking prof. Okay, leave me alone. Struct cell, right? So the struct cell is gonna have some properties that are gonna define kind of what it's doing, what it's like. That's it. Let's just make fluid simulation of some kind first, right? Because that's pretty simple, right? Like falling particles are like particles that fall straight down are easy to make, and then the next step is to figure out fluid. So a cell isn't going to have any information right now. It's just going to be that, and we'll figure it out on the way. So I'll make a class. I can't make another grid component. Come on, be creative. Sandbox component, public component. And the reason I have access to all of these, by the way, they're not in one header. It's just that there's engine thing includes all the E's, and that includes this, and ECS includes, like ECS.age includes component, and that's where we get the component, for example, right? So we have this entire header structure that makes it really easy to work with for me anyways. And we have this introspection system that we're going to use. So we are going to, object name is sandbox component. And that enables us to do a whole load of stuff that is really sweet. Like ask whether it is a sandbox component and that sort of thing. So we can actually, with a very with like what is a linear complexity? Not linear. Is it linear? Yeah, linear, not constant. It's linear complexity. We can figure out like, okay, um, world has or what is it, like entity has component, right? So we can ask an entity, hey, do you have this component? The reason we can do that in linear complexity with like not a lot of things going on is that we just compare strings. You know, this object name thing is an entire macro disaster, and we have another macro disaster here. We'll figure that out as we go. But sandbox component is gonna be constructed with, and I changed this recently, so I have to look it up. Right, we need to give it an entity reference, E, and let's give it some sort of size, right? So size W, size, actually, let's do a vec. Whatever, size TW, size TH. The reason I don't like this very much is because we have like ambiguous parameters, I guess, if you will. Like which is first, width or height? Nah, in this case, it's kind of clear. Yeah. So I don't know. That's just pet peeve. You know what I mean? Have those sometimes. And my caray navigation today is fucking horrible. All right, let's do size. You know what? This is kind of ridiculous. We should really be doing this like a vector. I like this, but let's do it as a vector, like properly. So size is WH, and then size is gonna be a vec of size T, I guess. All right, cool. My default size is gonna be like 200 by 200. Let's just make sure we have a default size, just because that's pretty. Or actually, I don't know what a good size is yet, so let's leave that for later. So auto sandbox is world at entity. Let's just do it there at 0, 0. I don't really care. We lock that to get a shared pointer. Add component. Sandbox component, and that will like construct it in place with the things that we want. So let's make it 200 by 150, and then let's make sure that size is, actually let's not do that. Let's test this shit later. I don't really care. All right. It should be enough. So now we can say virtual void on update. Is that constant? No, it's not. Override and on draw, which takes a draw surface or some shit. Okay, we have a simple drawable and drawable. That makes it easy to draw things on the screen. So a simple drawable is basically just an object that we can tell, well, I want to draw a rectangle here, draw it for me, right? And it kind of keeps track of all the, whether it has changed or not, and it's gonna register it with a draw surface and all that disgusting shit that we don't want to deal with at all. That would be a code smell, but it's not, because I hide it behind an abstraction. That makes it look like it's pretty and well designed, right? Pretty much all I do when I program, actually. Oh, the burn. Right. So we have all these beautiful, like it knows how to like load a texture, I guess. I don't know. Does it? It doesn't even know that. But the most important part is that it is actually just an array of vertices, right? And so we can just give it a bunch of rectangles as vertices, and it will draw them on one draw call. Pretty sweet. And for this, we're actually just gonna go over to this and we're just going to copy that. So we're going to say, we're going to copy a few things here. So first of all, we want to initialize the drawable the same way. Drawable, oh my god, drawable. As you can tell, it's 11:30 p.m. I'm not feeling too awake right now, but it's okay. Simple drawable. Primitive type quads, and then we do width times height times 4, because we have width times height, many rectangles, and each rectangle has 4 vertices, so it's width times height times 4, which in our case is 1280 times 720 times 4, which is a lot of vertices. Oh, that's cool. Why is it colorful? Calc wasn't like that before. Cool. Whatever, that's 3.6 million vertices that are rendered. And it's going to do that in like absolutely a breeze, right? Actually, that's 200 by 150, but we could... Why did I do this? Who knows? Who really knows? Okay, so let's go back to this and let's copy some rendering code. For the initialization, we're gonna just go with this. We're just gonna fill the entire thing. I know it's ugly, whatever. We're gonna steal the index 3 to 1 function, which converts an index, like a 3-component vector into a one, into like an index into an array, right? So what we can do okay, there's multiple ways to have a 3D sort of like a matrix, right? So a vector, a 3D vector, I guess, is a 3D array, whatever you want to call it. It's just basically a vector of a vector of a vector, right? It's like a vector of vectors, or whatever you want to call it. And so what you can do is you can actually do this sort of like standard vector of standard vector of standard vector. Or in this case, you can probably use a fucking vertex, like 4 vertices or some shit, like a vertex pointer raw array or some shit, or standard array. Vertex 4, something like that, but you quickly get into this point where you're like, how many of these do I have to put? And it's just fucking retarded. So instead, we use a one-dimensional array, or just a simple array like it would be in normal memory. And this is also more cache friendly. And I think, anyways, not sure about that. I might just be talking out of my ass. But basically, we have a one-dimensional array, and we treat it as if it's a three-dimensional array by using the correct indices. So if you think of a two-dimensional array mapped to a one-dimensional array, that's pretty simple, because you just take each row and put them behind each other in memory, right? That's super simple. So all you have to do is, like, when you go another row down, you just have to advance another row size element, right? I don't know if this makes sense, but it makes sense when I gesture it with my hands, which you can't see, which is great. But anyways, that's why we do this. We do the same thing with the three-dimensional array. So we say, like, we have the width, and then the sort of the depth, right? And those are two things that we store in a one-dimensional array, even though we should be storing it in a three-dimensional array. But this makes a lot of things quite easy. Not that it makes them really easy, but quite easy. As you can tell, that this is like not the most pretty interface, but it works for what we're trying to do, right? And so the color is gonna be right. So we're gonna have a type, right? A type, enum type deal. Maybe it'll be like a standard uint or some shit, right? So it's like pretty small, and that makes the cell, what, 1 byte? Okay. And so we'll have different materials, right? So let's start with something simple like dirt, right? And so that's going to be the type. And then depending on the type, we'll have a lookup table that like just gives us the corresponding color or some shit, right? So we'll just have like a static inline standard map of a cell type to, type to some simple drawable color, some shit, right? We actually don't have that defined. Let's do that right quick. Because we're just SFML things that we want to rebind so that they don't look like they're SFML, because that way I don't look as lazy as I am, right? It's pretty sweet. Okay, and then as color map, and we'll do this as like a static inline const expression. So static const expression, is that a const? Can that be a const expression? No. Okay, whatever, dude. Let's not have a const expression. Then let's just have it be const. And the way this is gonna work is we're gonna just have a bunch of elements, right? So dirt corresponds to to simple drawable. Oh my god, it couldn't be more difficult to write something so simple, right? Haha. See what I did there? Brown. It doesn't have brown. Okay, what's like a dirt brown and hex? Thank you. Wait, that's ugly. Whatever. So in case you were wondering how you can like do that here, you just do this. Pretty simple. And that should do it, but it doesn't, because we should be using cell type dirt. Okay, so this maps like a dirt to a color, I guess, right? And then we just make it a little static inline. Simple drawable color reference const to color for type cell type return as color map at type if as color map dot find type. Actually, does it have like it contains? It does. What the fuck? Okay, cool. That's the first time I've seen that. If it doesn't contain that, we just kind of assert not reachable, because this is not reachable, right? If it doesn't exist, we just forgot to put it in the fucking table, right? It's like not a big deal. Because this is not very cumbersome, what we can actually do instead is have this be an enum class. That makes a lot of things very easy. That way we know we're never going to be out of range for as long as we define all types here. Right. I guess this is going to throw. Is this throwing when we... Yeah, send it out of range. Okay, cool. We don't even need to assert. Right. And... Right, so all we have to do is we have to just say like color. Auto color is color for type. Okay, we need like a way to store all the cells, obviously, right? So a standard vector of cells. We'll just resize that right now, just so we don't go insane. Cells, size type n, width times height, I guess. So color is color for type, and we have messed the formatting up on that one. Doesn't like that, does it? Okay, there we go. The color for the type of the M cells at index 3 to 1, X, Y. Actually, we don't need this. We need a index 2 to 1. Fucking end me, holy shit, this is so much work. Just to get this to work, I should have, like... We should have like a function for this, right? Like, it's just fucking retarded. Like, this is just fucking retarded, honestly. So we'll do cell reference at. This is pretty fucking decent, not gonna lie. It is pretty fucking decent. I like it. We should get rid of that initialization. Instead, initializes our cells with like cells resize. And then instead of resizing it, normally we actually take we actually give it we give it width times height, right? But then we actually give it a default sort of constructed cell that every cell is gonna have, right? And so this is gonna be cell type dirt, for example, right? That's why we have say default. So this should really be air, you know, the default should be air, whatever. Leave me alone. Color for type, cells. Instead of doing this, we'll actually use add method here. Add xy dot type, right? And so now we get the color from the type of the cell, and we apply that to the whatever at the point or something, and then draw surface. So we just delegate that. Now, did I do that right? I don't think I did, because we need to set changed. Let's do that. And obviously we actually want to change it too, right? I guess this is set anyways, but whatever. Okay, let's see if this builds. How long have I been fucking talking without a single break? 30 minutes. Should become YouTubers, I think. Okay. That works pretty well. That looks like a 200 by 150 grid. We don't really see that it's a grid right now. Just to demonstrate that it is in fact a grid, let's just make it like A is random between like 1 and 254 or some shit. I don't know. Work, thank you. So that way you can see that they're actually different. See, these are different cells, yeah. Makes sense. I actually like that kind of the way that kind of changes the texture, whatever. Did that just crash? What is happening? Okay. I'm gonna just do a big ol' hope and say that wasn't me. Yikes. We should probably perf that. Not right now. Not right now. But we'll performance record that later. This is actually pretty sweet. Right, so you can see these as cells. And yeah, we're rendering these pretty fast. Like this is solid 60 frames a second. There's absolutely nothing wrong with this. Yeah. And so now they just have to update. And updating actually makes the rendering way slower, right? Obviously, because we're just drawing these with the same draw call over and over. We're not actually doing anything smart, but whatever. Okay. I think I'm going to call it here for this one. I'm just going to upload the next one right after. So if you're watching this, just watch the next one right after. It just makes it easier to go back to like a video and like rewatch it or find the place that where you were at. Because if it's like a 5-hour video, you're like, what the fuck was this? Like, where am I? What is even going on? So I'll talk to you guys in the next one. That's gonna be uploaded right after this. If you like it, leave a comment saying that you liked it, so that I know that you watched to the end. If you didn't watch to the end, then you're not hearing this. So if for some reason you figured out how to do that, then let me know. I would love to be able to time travel, and I'll talk to you next time.